Hello DSci 2000. In this video, I'm going to give you a very brief introduction to regression and classification in R. DSci 2000 is not a statistics course. If you want to get a more in-depth treatment of regression and classification in R, I encourage you to revisit or learn Math 1080 or 1090 content and try to execute that content in R. Or you take a course such as Math 2080, which is a course in stats focusing on regression, which also uses R. I'll be primarily focusing on just the execution of regression and classification in R, and just giving you a very brief introduction to what these concepts are. Note that there's a vast literature in regression and classification. I have studied regression and classification all the way to the master's level at this point, and there are obviously PhD level courses that you could also take on these topics. One resource I would recommend just as a starting point is the book called Introduction to Statistical Learning by James et al. In the textbook list of the syllabus, but you should not use that only as your only resource. One of the things I'll tell you from using regression and classification in a professional setting is that you need calculus and linear algebra to really understand what it is you're doing. I just want to repeat again, we'll only be executing regression and classification. What I'm presenting to you here is not how regression and classification would be done in a professional setting. You should take classes such as Math 2080 to learn more about these topics. And of course, there's much more beyond this at the undergrad, master's, and PhD level that we just do not have time to cover. So let's start off talking about regression. Here's an XKCD comic that you can look into if you're interested. We're going to work with the MT-CARS dataset, which is built right into R. As a reminder, the MT-CARS dataset is a dataset dealing with various makes and models of cars. Let's say that I wanted to build a regression line based on the variables weight and miles per gallon. And I'm going to use our knowledge of ggplot2 to build a graph based on these two variables. So let's go ahead and do this. Open up your DSci 2000 folder and create a new folder. Let's call it Unit 6. Open up your R project, close anything you currently have in here. Let's go to File, New File, R Script. The first thing we're going to do is we're going to load up the ggplot2 package. And I'm going to save this into the Unit 6 folder. Let's just call this Regression Classification.R. And before I forget, I'm going to go back to my DSci 2000 folder, right click, click on Git Bash here. Let's CD to our Unit 6 folder and do a git add on that R file we just created. Do a commit. And then let's do a git push. Let's minimize that. Let's hit Control Enter just to load the ggplot2 package. And then we're just going to follow this code right here. I'm just going to copy and paste this. I'm going to clean this up a little bit. And let's go to line 2, create this data frame, hit Control Enter. And then at line 6 right here, let's hit Control Enter. Let's go to the bottom right. And here's a scatter plot with weight in the x-axis and miles per gallon in the y-axis. So let's talk about how to run a regression line based on these data. How you run a regression with these data points is by using the LM command, standing for linear model. What you do is you create an object called M, which is a linear model. You put your Y variable on the left side right here, then a tilde, and then on the right side, you put in your X variables. In addition to that, you include an argument called data, which refers to the data frame on which you want to run the regression line. Let's go ahead and do that here. So here we're running a regression. So we're going to assign to M the linear model with miles per gallon on the left side, then a tilde, then weight on the right side, and then we're going to do data equals df. Put your cursor right there, hit Control Enter, and let's do summary M. Control Enter. Let's scroll down. So there's a lot of stuff here. I don't expect you to know what all of this stuff means. But remember, linear regression, all it is you're fitting points to a linear equation. The only things I really need you to care about for now are just this intercept estimate and the weight estimate. The weight estimate is like your slope of the linear equation, and the intercept estimate is just the estimate of the intercept of the linear equation. Remember that every linear equation consists of a y-intercept as well as a slope. So that means that my equation is is, in other words, 37.2851 minus 5.3445 times my x variable weight. So that would be the linear regression that would correspond to my points. So let's go ahead and plot this function in ggplot2. I'm going to copy this code and just paste it right over here. And it looks like it didn't paste quite correctly. I'm going to change this to a curly brace and this to curly brace, and I'm going to indent this. So here is that linear regression equation I just told you about, where this was your y-intercept and this was your slope. Let's put our cursor on line 14, hit Control Enter, and on the right, you will see that the regression line has been defined as a function. Going back to the left, remember that how you add a function to a ggplot graph is by using the stat function command. So I'm going to copy lines 6 through 8 right here and just paste them down here. And I'm going to add stat underscore function fun equals mpg regression with a plus sign right there. Let's just put our cursor somewhere on line 18, hit Control Enter, and look at the bottom right. There is our linear regression line. And that is what we just did here. Another way you could do this without having to manually type in the function is by using the gmsmooth command. So here's how you would do that. I'm just going to comment this out and press enter. I'm going to type in gm underscore smooth method equals lm in quotation marks and se equals false. Let's put a plus sign there and let's just hit Control Enter. And let's scroll down to the bottom right. Here is that same linear regression line. The advantage of using gmsmooth is that you don't have to manually define the function that is your linear regression line. That's all I'm going to cover on regression. If you have any additional questions, please let me know. Let's talk about classification now. So here's what I'm going to do. I'm going to create the same plot as we just did earlier, but we're going to color by AM. In mtcars, the AM variable refers to whether the car is manual or automatic. It's 1 if the car is manual and 0 if it's automatic. Let's go ahead and run this code. I'm going to copy this. And paste it here. And let's press Control Enter. Let's go to the bottom right. So here I have created the same scatter plot, except points are now colored differently depending on whether they are manual or automatic. 1 being manual and 0 automatic. So classification deals with the problem of, can you build a model that can accurately predict a categorical variable? In this situation, if I just give you a set of variables, can you predict whether a car is manual or automatic? The algorithm I'm going to introduce you to is the k-nearest neighbors algorithm. How this algorithm works is as follows. For every point, what you do is you find the k closest points to your point, and whichever classification is the most prevalent of these k points, you assign this classification to your point. That is all the k-nearest neighbors algorithm is. In some occasions, if k is even in particular, you might get a tie between two classifications if the k-nearest points to your point have an equal distribution between your two classifications, in this case manual or automatic. What you do is you randomly choose one of the two classifications for your point. Theoretically, you could use the distance formula to code this, and you could use loops to do it, but I'm not going to cover that here. I do encourage you to do this on your own though. What I'm going to do instead is I'm going to use currently existing code in a package called class. Let's go ahead and run this package. At the console here, I'm just going to type in install.packages class. And then I'm going to scroll up. Let's activate the class package. Press Control Enter. And let's just go ahead and copy and paste this code into R. We don't need to load the class package again. Let's run the setseed command, press Control Enter, and let's run line 31, press Control Enter. And now let's go look at the data frame df. So what you see here is this. AM is the actual value of automatic or manual for that specific car. Prediction is via the k-nearest neighbors algorithm, whether that car would be predicted to be manual or automatic based on the k-nearest neighbors algorithm. Let's see how well these two match. Let's go back to our R code. And I'm going to type in table df $am, then df, $prediction, and let's just do exclude equals null, and press Control Enter. What does this indicate to me? Of those that are actually 0, the k-nearest neighbors algorithm predicted that 16 of them would be 0, and 3 of them would be 1. And of those that are actually 1, the k-nearest neighbors predicted that 1 of them would be 0, and 12 of them would be 1. So, you can use this to compute an accuracy rate. The diagonal with the 16 and 12 indicate to me how many of them were predicted accurately, and the ones not on the diagonal, the 1 and the 3, indicate to me which ones are not predicted accurately. So the accuracy rate would be 16 plus 12 over 16 plus 12 plus 3 plus 1. Let's press Control Enter. And so it's about an 87.5% accuracy. Although this might seem like a very high accuracy, whether or not this is actually good accuracy really depends on the problem you're interested in and the context of the situation. I just want you to know that this is how you run a k-nearest neighbors algorithm, and you can gauge how accurate it is using the table function and by computing an accuracy rate. And that's really all I have for you in this video. I just want to end with a few closing notes. There's a lot of material I've skipped. There's a lot more study that you can do on these procedures, and if you really want to dive more into this, I recommend taking Math 2080 and looking at the Introduction to Statistical Learning text in the syllabus. The k-nearest neighbors algorithm, for example, is an example of a machine learning algorithm. If you want to dive more into that, you'll need to learn more calculus and linear algebra beyond what I teach in DSci 2000, as well as some statistics with calculus and linear algebra. If you're interested in going down this route, please feel free to schedule a one-on-one appointment with me. Let's go ahead and open up RStudio. Make sure you've saved this. Go to Git. Let's commit this. Now let's do a git push. And let's just close out of everything. I don't want to save my workspace image. And that's it.